Alright, today we're looking at modeling quadratic functions, and really the first part of this is just going to be writing quadratic functions. And the first attempt we're going to make at this is putting these things in vertex form. This is the easiest way to do this thing. Later we'll do this in standard form, which is a little bit more difficult. But for this one, to write these equations in vertex form, all we need to do is find the vertex, find the a value, and plug it into that vertex form. And remember that vertex form is y equals a times x minus h squared plus k. Alright, and the two things we need are the vertex and the a value, so those are the two things I find. So vertex being the hk, and then we find this a value, and then we plug it into this format. Alright, for example, if I look at the first one, it says to find the vertex and the a value. Well, here I have the vertex and the a value, so they're already found. I just need to plug them into that vertex form, so y equals a, which is a negative 2, times x minus h, and remember this is hk right here, and just be careful with your signs here. It's minus a positive 2, so it's just x minus 2 squared plus k, which is a negative 4, and then I might just clean this up a little bit. Instead of having plus a negative, I'm just going to rewrite this as a minus 4, and that's it. Looking at the next one, I do the same kind of thing. So I've got the vertex and the a value, just plug them in. Y equals a, which is a 1/2, times x minus h, and this time h is a negative 3. So again, be careful with those signs. This is hk, it's minus that negative 3. Oh, meant to switch back to my blue pen. So again, yeah, be careful with those, plus the k, and I'll clean it up a little bit. I would never leave that as minus a negative. I'm going to write it as x plus 3 squared and then plus the 2. Okay? This next one's a little bit tricky because I don't have the vertex this time. So I have to go finding the vertex. And when I look at this thing, this one's in standard form. Well, to find the vertex in standard form, I need the vertex and the a value here. The vertex in standard form, remember, I do the opposite of b over 2a. So in this case, the opposite of b is a positive 6 over 2 times a, which is a 3. So now I have 6 over 6, which is 1. And now I need to just plug that thing back in to find the y value. So I plug that in up here for each of these x's. So when I do 1 squared, I get a 1 times 3 is a 3, and I'll just write that down. Minus 6 times 1 is 6 plus 5. And so it looks like I end up with a 4 here, or sorry, a 2. So I get 1, 2 for my vertex. The a value is just the a value that I've been using right here. It was opposite of b over 2a, and I plugged a 3 in. A is this value right here. Okay, remember the a value from vertex form, the a value from standard form are the same a value. And now I can just write this thing, y equals 3 times x minus h squared plus k. That's it. If I have something in vertex form, and this time I want to go to standard form with it, so if I want to write things in standard form, if I look at this first guy, to go from vertex form to standard form, I essentially just simplify this thing. And when I say simplify, I just perform any order of operations, things that I can. I combine any like terms that I can. So in this one, x plus 4 squared is really just x plus 4 times x plus 4. I'm actually going to square this thing, so I'm actually going to multiply this thing out. That's what I mean by simplify. And so here I multiply this out. I distribute the x. That gives me an x squared plus 4x. I distribute the 4. That gives me a plus 4x plus 16. This minus 6 just kind of tags along for the ride. And now I just combine all my like terms. I end up with x squared plus 8x plus 10. And now it's in standard form. Y equals ax squared plus bx plus c. Alright, so I just multiply this thing out. For the next one, I approach it the same way. I'm just going to write this thing in vertex form first. I've got y equals a, which is a negative 2, times x minus h squared plus k, which is the minus 4. And now that I have this thing in vertex form, I just have to multiply it out. I just have to simplify in order to get it in standard form. So I've got the negative 2. Again, when I multiply this guy out, it's going to be an x squared minus 2x plus 4. And again, if you need to take that off to the side and do the x minus 2 times the x minus 2 and show that, that's fine. Okay, but multiply that thing out. Now I've got a negative 2 times x squared minus 4x plus 4. I'm going to go ahead and distribute that 2, or that negative 2 rather. And then I just have to combine like terms. And when I do that, I end up with this guy And that's it. This thing is now in standard form, and I can instantly check these a little bit. I could work backwards, find the vertex. I already have the a value. We can see that the a values match up, but you could do opposite of b over 2a to get the x value for the vertex, plug it back in to get the y value to make sure that this thing worked out okay. All right? The other way to do this one over here is I could set up a system of equations using the fact that this guy stems from the opposite of b over 2a. And then knowing that the a value is -2, then I could solve for the b value, and then I could plug it all back in and solve for c. And really, that approach is nice, but probably not as nice as just plugging this thing into vertex form and then solving. I mention it because if I look at something like these guys, I want to write the equation in standard form using a, b, and c. This approach I'm going to have to solve using a system of equations, all right? And so here's what I do for these. If I'm given 3 ordered pairs that are part of a parabola, I'm saying these points are contained on a parabola, I want to write the equation of that parabola, I essentially need to set up a system of equations where I solve for a, b, and c. So here's what I do to approach this. I just write down y equals ax squared plus bx plus c, but I do that 3 times. And the reason I'm doing this 3 times is because I have 3 variables, 3 things I want to solve for, so I need a system of 3 equations. And the other thing you'll notice is I also have 3 ordered pairs here. They're going to kind of help me complete these equations. And so I'm going to be plugging those values in. And so here's what I do. I plug that first order pair into this guy, and I get 0 equals a times 0 squared plus b times 0 plus c. And I plug the next ordered pair in here, so I plug the -2 in, and I plug the -1 in for x. And then the last one, I plug that 1, 6 in, so I plug the 6 in for y, and I plug the 1 in for x. And then from here, I just simplify these a little bit. In this first one, you end up with 0 equals c. This next one, I end up with a -2 equals 1a minus b plus c. And then this last one, I end up with a 6 equals a plus b plus c. And you see what I really have here? I have a system of 3 equations, and I've got 3 variables to solve for, a, b, and c. So if I kind of cut this off and say, hey, this is a system of 3 equations, how am I going to solve this system? Well, the obvious answer is to use substitution, because this first guy I already have solved for c. So I plug that c value in, I end up with this, -2 equals a minus b. Over here I end up with 6 equals a plus b. And now, again, I hit the reset button one more time and say, okay, now look at what I have. Now I have a system of 2 equations and 2 variables. So I'm going to bring this guy over here, and I'm going to solve this by elimination. If we look, this is perfect for elimination. I add these up, and I end up with a 4 equals 2a. I finish solving that guy and find out that a equals 2. I'm not done yet. I have to plug that in over here, so I plug the 2 in, and I'm going to solve this guy for b. I subtract the 2 from each side, and I get a 4. And so now, as I look at this thing, I've got all the values I need. I've got y equals a, which is the 2, x squared, plus b, which is 4, x, plus c, which is a 0. So this is the equation of my, sorry, I messed that up a little bit. So this is the equation of my parabola, okay? If I look at the next one, I do the same thing. I start with the 3 y equals ax squared plus bx plus c's, and I just plug one of these ordered pairs into each one. So like this one, I would plug the 4 in for y, and I would go ahead and plug the 1 in for x. Whoops. Plug an x in for x. Yeah, that's not going to help me. The next one, I plug the 6 in for y. I plug the -1 in for x. And the last one, I plug the 9 in for y, and I plug the 2 in for x. And then it's just going to be a matter of simplifying these guys a little bit. I did it again. I want a 2 in there. And now I simplify these. This one I end up with a plus b plus c. This one I end up with a minus b plus c. And this one I end up with 9 equals the 4a plus 2b plus c. All right? And then from here, I have to solve this system of equations. And really, you could use substitution or elimination, but remember also, we can just plug these into the calculator, and that's the method I would probably approach with most of these. Just remember, when you plug it into the calculator, you have to rewrite it so they're all lined up. You have to put them all kind of in standard form. And then this one, the 4a plus 2b plus c equals 9. And so when you plug this into the calculator, depending on what kind of calculator you're using, you go into the solving menu and you tell it the number of unknowns. Remember, you just punch the coefficients in. I know with the TIs, remember, you have to write this kind of as a matricy, where you put it like this, and you have to go into your matrix menu. I'm not going to get into actually showing how to solve this here because we already had that in a previous lesson. But suffice it to say, you basically use this, use the coefficients, and we plug it into the calculator and see what we get. And in this particular one, you get a equals a 2, b equals a -1, and c equals a 3. And when you actually do it in the calculator, it'll probably spit those out as x, y, and z. You just have to ignore the fact that it's x, y, and z because we're not using x, y, and z, we're using a, b, and c. And now you write your equation. And that's it. Okay. If you look at something like the next one, we've seen things similar to this before when we did linear regressions and whatnot. And we're going to kind of do the same thing here, except we might find out that when we graph this thing, we're not dealing with a linear regression. The other thing we also notice is that we're talking about time, and you have to be really careful when you're talking about time because if you look at this, 12 here and 12 here are not the same thing. They don't represent the same time. So you almost have to think of it like starting from a certain point and counting up from there. So like if I called this like the 8th hour of the day, this would be then the 10th hour, the 12th hour, the 14th, the 16th, the 18th. This would be the 24th hour of the day. And if we continued into the next day, I might use the 26th hour or the 28th hour, so counting up from a certain point. You have to scale it that way when we're talking about time, all right? And so now I'm just going to plot these things. So here I've got, let's see, 8, 10, 12, 14, 16, 18, 20, something like that. Over here, rather than starting at 0, I'm going to put a little zigzag in here and say there's a bunch of values that I'm not counting down there somewhere. So I'll call this 50. Maybe this guy's 60, so I'm kind of going 5 5s here, but I'm labeling every other 70, 80, 90. And now I just plot each of these points. I see what they look like. So 852 is around here somewhere. 1064 is around here. And I'm just plotting each of these. 1272. 1478 is around there. 1681 is around here. And then 1876 is around here. And so when we look at this thing, it doesn't follow the pattern of a linear equation. That's what we're used to dealing with. Before we would do linear regressions with these things, this one doesn't look like a linear equation. It looks like it's following a parabolic curve, so it's a quadratic. And so when I do this, I approach it the same way. I go into the graphing calculator, and remember I type these into my lists, and I put my x values in list 1 and my y values in list 2, where I do the 8, the 10, the 12. And just make sure you don't include the 24. Into list 2, I punch in these guys, the 52, the 64, the 72, and I keep going. And remember, when I do this, then I go into the statistics menu. But instead of going to what we call a linear regression like we did last time, this time we're going to click on a quadratic regression. Okay, so it'll say something like quadrag or quadratic regression. On the Casio calculators, you'll have to tell it that you want an x squared type of regression. And we just punch this thing in, we tell it to calculate, and it spits out a function for us. And when I do this one, the calculator spits out something like this. Y equals, I've got an a value of something like negative 0.469 x squared. Oh, I'm not going to give myself enough space here. Let me move it. Get these guys out of the way. And then for my next value, it looks like it gives me a b value of plus 14.716x. and then the C value, negative 36 point, we'll say 121. And those are all rounded off, and these are all kind of estimates. It's giving me the best approximation of what this thing could possibly be. And now what I can do is I can make predictions about this thing by plugging that 24 in. And when I do that, it gives me approximately 46.919. So we'll say about 47 degrees here when we're looking at the temperature. Okay? And so that's how this thing works. We're essentially just doing the same things that we've always done, and we're using the calculator in the same way that we always have, but now we're applying it to quadratics.